Good afternoon. Today's topic is overview of the new Fortran 2003. Actually, and I apologize for this in advance, I have somehow gotten the date mixed up from here, so I don't agree number of slides. In fact, I only have one slide. But fortunately for you all, I guess, then we can see some live example or demo of Fortran 2003 in use in code that was on supercomputer. So here's just give you the overview and actually just walk through the code with some examples of how this to talk through the features and show you how this is actually used or can be used. So you see just some bits and pieces of the feature of Fortran 2003 in the code that I'm developing or co-architect of. So hopefully next up for the lack of slides. And in the next couple of days I can add slides when this gets posted on the web. So there's a view of 2003 is Fortran 2003 is a major extension of Fortran 95. So, taking off or assuming that you're familiar with Fortran 90 or Fortran 95, this is some of the features there, and just we go from there. What's new in Fortran 2003? So this section basically there are four. The major thing is the data enhancement for object orientation. So this includes type point procedures, finalization, type extension, polymorphism, and word binding, and we'll go through all of this or the majority of it. Another thing is also interoperability with C. So Fortran 2003 defines standards on how you can talk C code, and there will be some example of how to call C from Fortran and vice versa. There are minor numerous things, and that goes into this section of miscellaneous enhancement, and some of them are constructor for structure, new allocate statement for allocatable data, and to allocatable array. Pointing is something that's very handy, and there's also some array construction syntax which is also handy. There are also input-output enhancement, and that I will not cover in this talk. So, just let's see. Resources, in fact, I will use some of this here. Is if you look at the Wiki, there are list of features there, and they also use it to keep track of what kind of feature Fortran has implemented. This small document here is more of an informal introduction of Fortran 2003, and very good. And in fact, we look at some of the examples in this document. There's a 2003 handbook, which basically takes at the standards and do elaboration of the standards. The handbook basically just follows the standards from beginning to end, and it just use that standard or a computer keeps going to see something. What we have. Let's see. Next. my screen is my screen connected? They can just screen sending. Okay, well, let's keep going. Okay, right into the code then. See what happens. Amazing. This is last second. Hopefully this is. What we have here is an example of web data type in Fortran. So what I call this is code. So there will be some other things that's not necessarily obvious in the module right away. But let's say I have a direct type called variable group 4. And this is where I want to have an array, and I have multiple integer variables, and whether or not my array is allocated. So what's the deal with type-bound procedures? So in Fortran 95, if you have procedures, you usually only has it in the module. So you specify a procedure. But with type-bound procedure, you can basically have a procedure that's attached to the derived type. So here's an example of a type-bound procedure. So this derived type has the data members, which is basically this, also have another type as a member. It also has a procedure attached to it. So in this case, initialize allocate is a procedure in the object-oriented parlance. It is a method of this derived type. So these are features of Fortran 2008. Now, I can have one procedure. In this, I have allocate, associate, and clone. So if you remember in Fortran 95, you can have an associate method where you can define multiple methods and refers to it by the same name. Similarly, with one procedure, I can define something called generic, and generic is the generic name in this case, which is attached to initialize allocate, initialize associate, and initialize clone. So if I call the procedure initialize, of which argument correspond with any of these procedures, the compiler or runtime environment will rewrite it to the appropriate subroutine. So this subroutine initialize, allocate, associate, and clone is defined in this module. This is how you define a module procedure. So here, for example, the definition of initialize, allocate, a list of arguments, and here's a definition of initialize, associate, and it has a list of arguments, and the argument here has to be differentiable from initialize, allocate, so that the compilers know where to reroute your function or where to rewrite your function call depending on this. So let's see. There is a new feature here is the access statement in 4003. So in this case, I declare that this subroutine as public. So that means all modules that use this module can access this subroutine. But similarly, I can declare this as private. In this, then other module outside of this module can access the subroutine. So therefore, when you want to hide certain information from users. So if you develop a function that you don't want users to have access to it, but you want to use it in your other function, you can hide that. You can hide our private member. So in this member, this is default as public, but you can in principle also put private here so that, for example, end values will not be people from other from another is the pass attribute. So here we have the key pass. What does that mean? So when this class allocate is called, the first argument is actually the type. So here you can see the first argument of initialize allocate is the type value form itself. So if you say call or call variable group initialize, then you don't need to actually pass because it's automatically passed. So this will become obvious when I open the functionally or the pass and actually call it. Okay. So the program that use variable form. So how do you use it? So you access just like you access the member. So here's an example. Here of 3D type variable group, here variable group form, and its initialization function or subroutine. So I just call 3D because it's I have to give it index initialize. And the first argument I say here is the value share. Although in initialize, the first one should be the type itself, but because of the path attribute here, when you call actually automatically this object or this instance here gets passed into the sub. So if with Java, this is just like saying this, and then the object this is what is being passed. So also here note that there's a comment that this is actually initialize allocate, but I'll only call this initialize, and because initialize is generic name of this argument, the compiler knows that this actually get routed to initialize. Also here, this the first argument now we call initialize, but this is actually get routed to initialize. So this example program is used to pass variable to. So the next new thing is well Okay. So final procedure is also a new feature here. So what it does is that final procedure actually is called whenever an object goes out of scope or an object is deallocated. So you can declare any procedure as a final procedure. So the keyword is final, and you give it a procedure name. So finalize is just some name, but you can call it anything you want. So this whenever an instance of variable group form is deallocated, so for example, scope, so the procedure finalize will be called. So in this case, here where you do, this is the procedure where you can do clean up. So in finalize actually deallocate all of the arrays that as a member of the variable group form. So this is when you need to do things before your object actually disappears. So just like the concept of garbage collector in Java or in C++, here you can, or declare, I guess, in C++, here you can also declare your own which is the final. Let's see. Is there anything special about on the final? Final. What if we just have a different procedure called destroy? Yeah. So the only thing that's special here is the keyword, which is the yellow keyword. The name of the procedure you can. Right. Well, what if I had a procedure called destroy, and I said a procedure? Then you will not know if you like this procedure public destroy. Yeah. Then you not know they will not, because the compiler or the runtime will not know what this is like any other procedure. You have to explicitly call it for it. You can say if you actually right here, you actually let's see. This actually do something like this. Destroy, and then the allocate. But then this is just like any other procedure that you have to follow. Now, if I destroy a final procedure, as this, when I did, it automatically calls destroy. Oh, so you just say the allocate. Right. You finalize. Right. Right. So the runtime, the compiler is that. In fact, you don't have to explicitly allocate. So, for example, if you have a subroutine where you have this variable object where you have PG variable group, when you finish the subroutine, all the variable that is subroutine is out of scope. Right. So it's out of scope, it automatically calls procedure. Automatic destructor. Yes, thanks. So in this case here, I don't explicitly call the allocate, but because it's at the end of the program, it will also call final, because at the end of the program, everything gets the allocate. Okay, so let's see. Looking at notes. Let's see. Next thing, extension. That's the fun. I'm going to extension works like this. You have you have and you want to you want to create a new type to build that type. In the past, all you can do is just you can use that type. You can use that type as a member of your new type. So extension, actually, you can extend your previous type as a new type. So not really a compound type, but rather you just extending the old type. So this is in object oriented. This is known as inheritance. You inherit the type of your previous of your type, yes, and you create a new child. So just through an example here to make it clear. Suppose I want to where this is useful is if you want to implement a new integrator, where you have in principle you can have many different methods. You can do a Ranga kata to integrate your ODE. You can do first order Ranga kata, or you can do second order Ranga kata, or you can do another precision corrector integrator. But then here is where you have similar things to do, where you have a similar name of routine, so that from a user perspective, you switch and you don't have to switch all of your code. Suppose to change from first order to second order, then I can just change one line and change order without actually changing all the name of the code. So this is what we have here. In fact, I have here as an example a stepper, which I call as sort of the base type is a template. This is just name. You can name it anything you want. And in this case, it's an abstract type. An abstract type means that you cannot actually have an instance of this type. So you cannot have type template. So an abstract type means it has to be extended for you before you can use it. But in this abstract type, I declare all the things that I thought I'm going to need in so here I have three basic rules. I have an initialization. Again, I have an unloaded initialization where different things can be initialized, depends on the argument, and I have a step, which is where we do my integration step, and I have a set in this case, and I have a clear. This is for a physical reason. I have the important thing here is step. So when you note here, I declare step, but a new keyword called the for. In this, I do not have, because I don't know what the step is going to look like in this format. So for means I do not have to actually have actual definition of step. So in this step, it's just placeholder. Okay. Why is blocking? I think it works now. Wait for my network to connect back. Back on. I've lost my network. Hopefully it's good. Oh, there we go. Okay, so let's start this over the first. Yes. So in case step is because it's a deferred procedure, it's not necessarily it's not have to be defined in this module. So let's see how this gets extended. So in this step rata second order is an extension of step, and the way you do that is by saying how to extend step template, and then you get a new name. So we have one member here, extra member here, but in actuality, all the member of template is inherited by this step Rangakata second order group. So this step Rangakata not only have grid stream, but it also have all of the members here. Okay. So thing that I did here, I redeclare the subroutine initialize. What this means, when type is expanded and you declare the same name as with that, this is called procedure overriding. In this case, initialize for step Rangakata second order override for initialize of step. Now, have not only have two routines here. If I open step template, step has 6% or 5. But I also has all of the procedure, but in this case I override initialize and step. Remember, step was the first procedure, so in this case where I override it, I have to actually have the definition of the procedure. So in this case I declare, or I have the lines over there, the first and the development. So here I have all what that actually needs to do. So there's the extension, so you can keep extending your type. I this is a more complicated random data stepper. In this is also an extension of step template, and it has its own way to do stepping. Okay, going back to here. Next to cover is polymorphism. Polymorphism basically means that you can, I think, it's a way that different data types. In this case, we have type extension. You can variable as step template or as a class step, and you declare your variable as class step. You declare function definition as class step. You will actually take all the inherited and its extension. So you look at polymorphism is by looking at this example. Is where you do some sort of generic program. So let's take a look at the example. Let's see. Yeah, polymorphism. Okay, so so you can, if you know a sorting algorithm, then you can do bubble sort or quick sort. And the issue here is how do you write one algorithm that works for all kind of data? So Fortran, then you have to have sort industry, sort real, sort different kind of kind of data. So you can declare something like, in this case, for example, my argument is of class star. Class star means it's unlimited polymorphism. It means it has any kind of data type. So A here can be integer, real, complex number, different kind. And in this case, so thing to access this A input, I have to say select type. So select type. If type is integer, then and select is real, then I do the different sort of thing. But you can, to help you, can have different files generic where just declares the actual algorithm to the source. Then source has knowledge of, for example, types, but it's just because it doesn't matter whether A is integer, real, or complex, the algorithm remains the same. So this is not where you can do this sort of thing with polynomials. And talk about the code binding, and talk about abstract type. You another example of inheritance. Okay, here's the example of inheritance polynomial. Remember the selecting step. Remember is a way to solve short. So there are ways to, there are two methods to do all of the class of the method is called Riemann solving. So you can do a method called SL, you can do a method called SLC, and use different approximation and different variations to actually solve the problem. In this case, what you want to do, or what I decided to do here, is I have a template where all of the class of Riemann solver problem will have, for example, will need, Riemann solver always needs an output and always needs a plot, and it always needs variable plus or minus. But that's all I know, and depends on what method, depends on what kind of method I want to use. It's used to, so it always needs to set an input, and it always has a method called solve. So the implementation then, written on, for example, if I have the SL solver, then this is just an extension of the template, and I'll write the initialization and the solve method, because it's where the method is where the action method is for. So this is way to solve, and if I'm extension, the XRC is also on solve method, and more stuff, because this is a more sophisticated solve. So we can use that extension. So let's see, let's keep on interoperability with C. So let me see. This is the okay, and I mentioned earlier, and I really recommend you to go through this document and look at a feature that in Fortran 3, but show here is let's go to example real quick. If you for 495, if you get a new allocatable array S, for example, or allocatable array A, this variable C or the function D, then you have to do this kind of thing. You have to first look at the size, and then you locate A, and then you assign the output of compressed to A. So 90 on Fortran 2003, you can just simply do this assign. A is in this case, it's an allocatable array, and if A is not allocated, or if A is allocated with a different size, we will automatically get reallocated to the size equal to this. Now, in compiler, for example, in grep compiler, this feature is actually turned off because this can lead to dangerous situation with regards to performance if you're not careful. If you're not just and you just this assignment, then read memory, and then you may not get what you thought you get. So it's something where so there is about the associate construct. Which is really the associate basically just gives you an address to do this sort of thing. So you associate C in this with an expression, and that construct you can just use C. So in the past to do there's no way to actually do this with an expression. You can do pointer to a variable, but then rather than using pointer in the past, the Fortran 2003, you can actually just use an associate construct. So that's also something that's really, really useful. That's good. The interoperability. One of the most so in 2003 declare or define several intrinsic type map with C intrinsic type. So at least here where if you imagine about Fortran time, so you can have a kind of C in and map with, for example, in this case, the C, and so this is basically mapped with is on the right hand. You can use it, then you can have more definite association about what variable type to use when you want to call C subroutine. So let's take a look at how we can do that. Code. All right, example. So if I have a library or silo library of scientific data structure, but unfortunately, the library does not have a C or does not have a Fortran complete Fortran interface. Then I actually create a Fortran verse that maps to the silo library. So for using this new thing, and I can new a name of the derived type. This I map one-to-one with a C data structure. So in the silo libraries, there is a data structure called table of contents that has C pointer that have integer, that have pointer, integer, pointer, integer. So I now declare as a data structure in Fortran, which maps the type exactly, and in case the C struct is now accessible from Fortran by finding this to the corresponding type in C. So there's another thing I want to do here. So in this, let's scroll down. C function called get coordinates with the corresponding Fortran subsystem, but make a corresponding Fortran interface, and I call in this case CDP get coordinates, just to differentiate to the linking, which is in this by using the phrase I tell this function here in Fortran is or it actually is to the C function that the name is this. So this is the keyword find C and the name of the C function. So that makes sense. So and also in this case the argument is also the dp get coordinate is pointer. So in this case I have to make the argument of this Fortran of type pointer, and the second argument is a string. So in this case, I make the argument of this Fortran function is the n of C character. So by writing this wrapper first, therefore the C function from the Fortran. In fact, if you're familiar with FFTW, FFTW respect, it's written completely in C, but then they have the way they provide interface to Fortran is by actually creating this sort of interface wrapper so that any Fortran code can now call FFTW with the set Fortran design. So let's look at one quick example, last example. Okay. C function. All of the question is okay. Here's an example of Fortran importance. So this is the prototype of the C function, where it requires a pointer of sandbox, an integer of sandtown, an integer of, and an integer of reference. So you create an interface in Fortran. Integer, so this on the interface also reads the function also reads an integer, and this for the C for C library function. A statement sandbox, sandtown, and receive count, and EC finding, which is an intrinsic module defined by the standard. It's obvious that so the type of the first argument has to be C pointer, and it means that it will pass the value of 10 so this is a C pointer. This is just an integer, so it's an integer. And the document is also a pointer, so the type is also a C pointer. The other is C that uses void or this integer. It's all goes to C pointer. So in fact, this is that you just function. This is the Fortran interface. So there's a new function called clock, which basically gives you the address of this variable. So the read C-log is actually address to this variable. So this is in C, this is similar way you use if you family you use the ampersand to pass to a pointer argument. So corresponds to the ampersand sign in C as the address of a variable. Also, and basically most of the new Fortran 2003 standard with all of this. So go to resources. If you look, there's the code I show you is Genesis, and actually in the process of submitting or working on a paper that describe all the feature of Genesis from the ground up. So there will be a series of papers, but a lot of discussion on how we use Fortran 2003 to build it. So if you first, you can look at it, look at the paper, which is still a work in progress, this address. I'm also this library PSPFFT, which I'm bigger version in Fortran 90, but a new version is being released right now, and it should be up on the web page soon that use Fortran 2003, and this is, in fact, this has been adopted somewhere in Genesis, so you can take a look at that. This is code that's written in Fortran 2003, and as I mentioned earlier, as a tutor, we use Fortran 2003 to provide Fortran interface. So it's more widely supported now. There's a wiki here that describes the compiler status for Fortran 2003. Great compiler support all of the Fortran 2003 standards. In NAC compiler also support most of it, and a few bugs are being worked out by different compilers, different bugs, and G has or the final procedure to the development version, but in the release version there is no final procedure yet. Again, it's making good progress there. So I don't know if that's on the radar at all. Even Fortran 2008 is not major as Fortran 2003, but there are major piece of it which is co-array Fortran, and that to support that with the compiler is also still slowly being adopted. They evolve needs, yes, in that sense, and they have been up for the new standard beyond 2008, and they're pretty much dependent of what the compilers are doing, but and what they so Fortran at some point in the past, there's someone or it was forked into high performance Fortran. You basically, and then there's something for which is of cheap Fortran. Work on something that looks core Fortran. Basically, use Fortran to address memory on a remote distributed machine on different like distributed computers. So they look this kind of thing, and then it's just now that the Fortran died off, basically. But the comic experience that some of the features is useful to be standardized, and that's what I'm now the core. So there's all kinds of So different implementation of something that looked like Core Fortran in the past, P95 is one person, but then now it's adopted as a standard so that everyone can work together with support. Basically, if you use P95, then you can use that feature so that you can use that. So it's not very, yeah. Okay.